So now, excuse me, the concept of concavity. And this word has come up a few times in some of our discussions without us really knowing what this word is, intending to communicate to us. Concavity is the idea of how a function curves while it is increasing or decreasing. Because I could have a function increasing and curve this way, or increasing and curve this way. Decreasing could curve this way, or decreasing and curve this way. And in each case, there are two different possibilities. So concave up, or to kind of describe what that picture looks like, smiley face. And we abbreviate it as CCU. The definition of concave up is the first derivative is increasing, meaning that as I move from left to right, the slope of the function is getting bigger. So it's not that the function is increasing, it's that its slope is increasing. So in my examples here, if I move left to right, drawing tangent lines, I can see in this one, this would be concave up because the slopes are getting bigger. With decreasing functions, kind of the same thing. Remember, this is a negative slope. Well, the slope is increased, and the slope is increased again to make them less negative. So this would also be concave up. But like I just discussed in the last video, in calculus, the way we know that something is increasing is we see if its first derivative is positive. So if I want to know if the first derivative is increasing, I look for where the first derivative's derivative, or second derivative, is positive. So the definition of concave up is the first derivative is increasing. The way we find it is we find where is the second derivative positive. For concave down, that makes a frowny face, and we abbreviate it as CCD. This means that the first derivative is decreasing. So as I move from left to right, the slopes are getting smaller. So if I'm looking at my increasing sketch here, as I move left to right, those slopes of those tangent lines is decreasing. So that would be concave down. Again, it's not is the function decreasing, it's is the slope decreasing. And then for my decreasing function, as I go left to right, while the slopes are getting steeper, they're negative, so they're actually decreasing. This would be concave down. And again, the method of finding where a function is concave down is we look at where the first derivative is decreasing, which means its derivative, so the derivative of the first derivative or second derivative, is negative. So an example of this would be if I have the same function I just did with increasing, decreasing, and said, let's find the concavity. So the first derivative, we already said, is 3x squared minus 4. And we found where that was increasing and decreasing in the last video. But if I want to know its concavity, I then need to know, well, where is f prime increasing and decreasing? So to figure out where f prime is increasing or decreasing, I need its derivative, or f double prime, which would be 6x. And again, I kind of think of it in terms of like critical points. They're not really called critical points, but they're the critical points of f prime. So critical points of, that looks too much like f double prime, of f prime. Well, f double prime would equal 0, and f double prime undefined. Well, 6x is linear, so it is never undefined. And 6x equals 0 when x equals 0. And I then, again, sign chart makes this the easiest way to do it. I only had that one. But this sign chart is for f double prime. So picking something less than 0, and plug it into f double prime would be negative. Bigger than 0, f double prime would be positive. Now what this means is this tells me that f prime is decreasing for x is less than 0, and increasing for x is bigger than 0. Now note that's f prime is increasing and decreasing, which means that f would be concave down when x is less than 0, and concave up when x is greater than 0. So, oops, I don't want to go to this yet. So what I have here then is at 0, my concavity is changing. So at x equals 0, my function changed concavity. It didn't change direction, it just changed how it was curving. This point is called a point of inflection. It's like an extreme value for the slope. So just like an extreme value for a function only occurs when my function changes between increasing and decreasing or vice versa, an extreme value for f prime would only occur when its derivative, or when f prime is changing from increasing to decreasing. In other words, when concavity changes. And we call that a point of inflection. Please note, to be a point of inflection, the concavity must change. If I had had concave up on both sides, not a point of inflection. If I had had concave down on both sides, not a point of inflection. The concavity must change. So then this leads to some confusions because we have similar steps we're going through with f prime and similar steps we're going through with f double prime. So kind of summarize it all in one spot here. F prime changing signs means that f is changing direction, going from increasing to decreasing, which would be f prime is positive, going to f prime is negative, or from decreasing, f prime is negative, to increasing, f prime is positive. If f double prime is changing sides, that means f's concavity is changing. So concave up to concave down would be me saying that f prime, concave up means f prime is increasing, which means f double prime is positive. Concave down means f prime is decreasing, which means f double prime is negative. And then kind of that same idea when we switch from concave down to concave up. So if f prime changes signs, we have an extreme value. If f double prime changes signs, we have an inflection, point of inflection.